So the question says the level shown in tube 1. So we're assuming that what's shown in tube 1 is level, so we'd want to extend this line across all of these places. But it does say vertical. If tube 2 is vertical, well, yeah, you could put your ruler at right angles to tube 2 and say, what? The question specified it was vertical. If that's vertical, that's level. But I think you should use the indicated level and assume that when they say tube 2 is vertical, what they mean is that if you were over here looking that way, it would appear vertical. Yeah. The further a swimmer dives below, it should be farther, a swimmer dives below the surface of the sea, the greater the pressure on the swimmer. Explain why. Because there's more mass of water above him, or her, or them, being pulled down by gravity and pressing down on them per square metre. How many marks did they want there? The deeper you are in the water, the more water there is above each square metre of the layer of water in which you're swimming, and the more pressure the weight of that water is applying on it, and therefore on you. A person swims from a depth of 0.5 metres to a depth of 1.7 metres below the surface of the sea. The density of seawater is 1.03 kilograms per cubic metre because it's salty. Gravitational field strength is 9.8 newtons per kilogram, so this person is not swimming in the same place as that child dropped the ball. Calculate the increase in pressure on the swimmer and give the unit. Use an equation from the physics equation sheet. Oh my goodness, I don't have the physics equation sheet. We're going to have to go and find it. Download insert for all papers. Pressure due to a column of liquid is height of column times density of liquid times gravitational field strength. That was the question I just answered. Yeah? The height of column increased. Nothing else changed. Of course the pressure increased. Yeah. That's probably the one they want. And it doesn't include units. That's alright. 4 marks. The change in depth is 1.2 metres because they want the increase in pressure, so we'll have a change in depth of 1.7 minus 0.5, which is 1.2 metres, multiplied by 1030 kilograms per cubic metre is going to give me, multiplied by 9.8 newtons per kilogram, because we don't want kilograms per square metre, we want newtons per square metre. 9.8 times 1030 times 1.2 equals 12,102.8 newtons per square metre. There's actually a space for the unit here as well. Could of course call this 0.121 hectopascals if you really wanted to. Figure 7 shows the apparatus a student used. Why is there always students, not researchers or just members of the public who are curious about something? To investigate the reflection of light by a plane mirror. Oh no, it said plane. The student drew 4 ray diagrams for each angle of incidence. Okay. The student measured the angle of reflection from each diagram. Table 2 gives the student's results. What do we have? Raybox, which is just a light in a box with a slit in the front. That's all it is. Paper, so it gives something for the light to show up on. Total vacuum everywhere else apparently, there's no tabletop or anything. Plane mirror. Yes. Also known as the door off the bathroom cabinet. Reflected ray. Yeah. Why do we draw 4 diagrams for each angle of incidence? Why not just do 1 for every degree? Conclusion. The student sucks. I mean, he's within 2 degrees. Oh no, he's 3 degrees off there. 3 degrees, 4 degrees off that, 6. Conclusion, your mirror's shit. For each angle of incidence, the angle of reflection has a range of values. This is caused by an error. What type of error will have caused each angle of reflection to have a range of values? Shoddy construction of the mirror, Lousy positioning of the Raybox. Lousy measurement. Human error. Suggest what the student may have done during the investigation caused each angle of reflection to have a range of values. Used a shoddy mirror. Positioned the mirror not quite exactly on the 0 line of the protractor he drew on the piece of paper in order to set this up. Positioned the Raybox not exactly along the intended incident angle. Estimate the uncertainty in the angle of reflection when the angle of incidence is 50 degrees. Uncertainty is plus or minus something degrees. Well, you could go 56 minus 46 is 10 and halve it, but then you'd have 51 plus or minus 5 degrees. And all they want down here is plus or minus something, so we'd have to call it 6 degrees. Given how crap the results are, I'd maybe call it 8 degrees if I was actually doing this. Explain whether you agree with his conclusion that the angle of incidence is equal to the angle of reflection. I'd just call it inconclusive and tell them to go away and try again with a better mirror, and this time pay more attention. Draw a bigger protractor on your paper. Use a bigger sheet of paper. Use a better polished desk with fewer bumps in it. Wouldn't accept or reject his conclusion based on the shoddy data given. What extra evidence could be collected to support the student's conclusion? Try again with other mirrors on other surfaces. Larger drawn protractors. And at more angles. One change the student should make to the apparatus if he wants to use the same method to investigate diffuse reflection. Breathe on the mirror. He'd have to use something that isn't a plain mirror. He'd have to use a diffuse reflector. Piece of white card or something. There are no questions printed on this page. Do not write on it. Figure 8 shows a boat floating on the sea. The boat is stationary. That's quite an achievement, mate. That's quite an achievement, considering that seawater is moving, the air is moving. I mean, you can see a flag on the back of the boat being blown out here by something. Figure 9 shows part of the free body diagram for the boat. Complete the free body diagram for the boat. Well, 1 centimetre is 5 kilonewtons. Weight is down. Floating. Not being driven into the wind, but floating. I'll put another arrow pointing upwards, the same length as that, which is buoyant force. But there probably ought to be wind resistance pointing one way and thrust pointing the other, also equal in length. Stationary relative to what, anyway? Stationary relative to the water mass or relative to the nearby land masses? Well, if the nearby land masses are divergent. Calculate the mass of the boat. Information given in figure 9 and gravitational field strength of 9.8 newtons per kilogram. Measure the length of that in centimetres, multiply by 5,000 to get the weight in newtons, divide by 9.8 to get the mass in kilograms, and give your answer to 2 significant figures. When the boat propeller pushes water backward, the boat moves forwards. The force in the water causes equal and opposite force to act on the boat. Which law is this an example of? Newton's third law of thermodynamics. Could also be described as conservation of momentum, but that's might be a bit of a stretch for GCSE Physics. Figure 10 shows the boat towing a small dinghy. Tension force. Why is the tension force pointed in one direction? Tension force goes both ways. Causes a horizontal force forwards and a vertical force upwards on the dinghy. 150 newtons and 50 newtons. Your rope is too short. 150 forward, 50 up. Draw a vector diagram to determine the magnitude of the tension force in the tow rope and the direction of the force this causes on the dinghy. 4 marks. Right, what you would do is draw a thing 150 something long and another thing 50 the same thing up, and then draw the other side of the triangle as the sum of those two vectors. Measure its length for the value of the tension and measure the angle for the direction. A student used a simple transformer to investigate how the number of turns on the secondary coil affects the potential difference across the secondary coil. The student kept the potential difference across the primary coil fixed at 2 volts. It has an anomalous result. I've got to say, if you're keeping a fixed potential difference, you're not using an alternating current source, and you're not going to get any output from a transformer with a direct current source. But we'll let them get away with that for now because it's only GCSE. Number of turns on the secondary coil and potential difference. Yes, they're proportional apart from one anomalous result. Suggests a reason why the anomalous result occurred. That's 20 and that's 25. Maybe he only put, or she only put 10, 15, 20, 25, 23 and a bit coils? Nah. Just made an arse of reading the results. Or, voltmeter connection was a little bit flaky or rusty or dusty and didn't quite connect properly. Transformer changes from being a step down to a step up. How can you tell from figure 12 that this happens? The student kept the potential difference across the primary coil fixed at 2 volts. So here, the output went from less than 2 volts to more than 2 volts. Continues on the next page. A spot welder is a device that uses a transformer to produce a large current to join sheets of metal together. Bzzt. Figure 13 shows a transformer demonstrating how a large current can heat and join 2 nails together. Okay. How does the amount of infrared radiation emitted by the nails change when the power supply is switched on? It'll increase. It just says 1 mark down here. It'll increase because they're going to get very hot. And hot things give off energy by EM radiation, including in the infrared range. They're going to get hot enough to do that. If they're hot enough to weld iron nails together, they're hot enough to give off infrared. They're hot enough to give off visible light, which is higher frequency and therefore higher energy per photon than infrared. Calculate the current from the power supply needed to provide a power output of 336 watts. The transformer is 100% efficient. Woohoo! Can I get one for my Scalextric set? Because damn, the transformer in that used to get hot. Right. We know this is 1.75 volts. Bink, bink. Across here. And 336 watts. We know that this thing has 160 times as many coils as this. So it's going to be 160 times 1.75, 280 volts. Interesting. What are we supposed to be calculating? The power supply needed. Well, actually, screw it. The current's got to be. If this is 100% efficient, the current is actually going entirely into this. 100% efficient transformers. Sorry. So, all you really need is that the current there is 336 watts divided by 1.75 volts, which is 192 amps. There's your current. Already. Because this is at a much higher voltage, same power is at 1/160th, help if I typed correctly. 1/160th of that, which is 1.2 amps, which is not going to cause your house to just, flash auto-ignite. The satellite is in a circular orbit around the Earth. Figure 14 shows the velocity of the satellite at two different positions in the orbit. At this point, flat earthers fail by standing up and screaming and tearing the paper apart and throwing all their pens and pencils and erasers and any crayons they haven't eaten yet across the room. Explain why the velocity of the satellite changes as it orbits the Earth. 3 marks. Because it's being accelerated toward the centre of the Earth by the force of gravity, because this is GCSE Physics and we don't do Einsteinian field equations here. Because it changes direction. I mean, this is GCSE. Length of a satellite orbit depends on the height of the satellite above the Earth's surface. Wow. This is getting more advanced than I expected. Oh, length, not the length of the orbit, not the period of the orbit. It's the actual physical length, not the length in time. So this is going to be a lot simpler. Height above the Earth's surface in kilometres plus radius of the Earth multiplied by 2 times pi equals length of orbit. 7.73 kilometres per second. 300 kilometres above the Earth. Does this sound familiar? Calculate how many complete orbits of the Earth the satellite will make in 24 hours. Right. 300 kilometres. It's here. And oh look, isn't that convenient? It's exactly 42,100 kilometres around at that altitude above their convenient Earth. At 7.73 kilometres per second, so it is 41,000 kilometres divided by 7.73 kilometres per second is 5,304 seconds per orbit. If we divide that by 86,400 seconds, which is 24 hours, we get that is 0.061389 of a day, reciprocal of which is 16.28956. It says how many complete orbits, so the answer is just 16. 16 times 1.5, which is how many hours there are in an ISS orbit, is, 24. Oh yeah, it is the ISS-ish. It's not quite right, but no. In 1772, who cares? This is physics, not history. An astronomer called J. Bode, good for him, or body, I guess, developed an equation to predict the orbital radii of the planets around the Sun. Predicted radii and actual orbital radii that were known in 1772. 60, actually 58, 105, actually 108, 150, actually 150, 240, actually 228, 780, actually 778, 1,500, actually 1,430 million kilometres. The predicted data can be considered to be accurate. Give the reason why. Well, they're all within 2%. Will that do? They're all within 2%. They only want 1 mark. Use this equation to predict the existence of a planet with an orbital radius of 2,940 million kilometres. Planet Uranus was discovered in 1781 with an orbital radius of 2,875 million kilometres. Explain why the discovery of Uranus was important. Explain why pronunciation matters. It confirmed the equation. It's a prediction made by something, and it was an observation that confirms it, so it means it can now be accepted as a theory. I'm sure there's more information that's missing from this question. I'd love to know what his actual equation is. Light is usually described as a wave. Light can also be described as a stream of particles. These are 2 different scientific models of light. Say hello to Schrödinger's cat. Which statement describes a scientific model? A small-scale version of a real object? No. And no Miranda Kerr isn't the correct answer either. Even if she gets a degree, a way of guessing what will happen. No. An idea used to explain observations and data. I'm going with that one. Why do scientists sometimes have different models, like the wave and particle models of light? Because they make different observations, get different data. Different models explain different bits of it more tidily. Explain why scientists replace an old scientific model with a new model, because it explains everything the old one did and more stuff besides. Or it explains things better, or it makes smaller errors in its predictions. Include an example from physics in your answer. Scientists replaced Newtonian gravitation, G equals big G m1 m2 over r squared, with Einsteinian field equations because they more accurately predict the behaviour of subatomic particles, light passing black holes, even our own star actually, just anything travelling very near the speed of, or at the speed of light, and the precession of the orbit of Mercury. You could also replace miasma, open quote, theory, close quote, with germ theory, because miasma turned out to be bollocks and germ theory turned out to be right. But I don't think they want you to write bollocks on a GCSE Physics paper. Also, that's biology. Some students, these very active students, used water waves in a ripple tank to model the behaviour of light waves. Going from deep water to shallow water, you get this bend at the boundary. Hurrah. Explain why refraction happens. You don't have to know this is happening, you just have to, that it's called refraction. You can kind of infer it from it being in the question. At the boundary between the deep water and shallow water, because waves move more slowly in shallow water, and the decrease in speed at this end of the wave causes it to lag behind the parts of the wave that have not yet entered the shallower water. Wavelengths travelling parallel to the boundary between deep. Notice that the distance between them is decreasing, decreased wavelength. Why they do not refract at the boundary? Because the direction of travel of the wave is normal to the boundary. Means perpendicular. Also known as the angle of incidence equals 0. Angle of refraction, sine of angle of refraction equals sine of angle of incidence multiplied by optical density of first medium divided by optical density of second medium. But if the angle of incidence is 0, the sine of it is 0, so the sine of the angle of refraction is going to be 0, so the angle of refraction is 0. The circle in figure 18, with a cross in it, represents a straight wire carrying a current. The cross shows that the current is into the plane of the paper. You don't even have to know how to draw a wiring diagram here. Complete figure 18 to show the magnetic field pattern around the wire. Right hand grip rule, I believe. Point your thumb in the direction of the current, wrap your fingers around, and they're the direction of the magnetic field. Magnetic flux density 10 centimeters from the wire is 4 microtesla. Which of the following is the same as 4 microtesla? Is it 4 times 10 to the negative 2 Tesla? 4 times 10 to the negative 3 Tesla? You don't even have to know what Tesla are. You just have to know that micro is 10 to the negative 6. It's that one. 1 mark. Figure 19 shows a simple electric motor. That was all you had to know about magnetic field strengths, apparently. Coil axle, coil, magnet, carbon brush, split ring commutator. Yeah. When there is a current in the coil rotates continuously. Explain why. This is assuming it was already rotating, actually. The current will flow. Man, that's an ugly drawing. Current flows from positive to negative. The electrons are flowing from negative to positive. Because fuck you all, that's why. Current flows from positive to this half of the split ring commutator to whichever... So where's carbon brush pointing at? Where's that pointing? I think it's meant to be pointing at one end of here, I don't know. To whichever end of the coil is in contact with this side of the split ring commutator, and then flows through the coil, making it function as an electromagnet, to the other end, into the other half of the split ring commutator, and to the negative end of the power supply. This thing functions as an electromagnet, but the current is going that way on that side, field this way, and that way on this side, field that way. So the field on the outside is up there, and, excuse me, that's up there, and also up on this side, and it's down in the middle. So you have a magnetic field that is going that way through the middle, which will naturally flip to a line. You have a north-south magnet, north-south, it'll naturally flip to a line with this magnet. But as it rotates to do that, these ends of the coil switch as it's vertical, as it's approaching. Right, it's nearly vertical now and they're nearly out of contact. So as it goes past the vertical, the which wire is in contact with which half of the split ring commutator switches the alignment of the electromagnet. So suddenly it's going the other way. It's pushing the other way. And I'm sure they've drawn this thing out of skew. And the fact that it's already rotating means it has rotary momentum, which is going to carry it past the gap to the other side each time, which keeps applying that force that keeps rotating it. End of questions. Now this would be a lot better if your split ring commutator was actually multiple split rings at different angles, and you had multiple coils, each one acting on each commutator, so that the thing was always getting its power at exactly the optimum angle. Actually, you don't even need the multi-part commutator, you just need the multiple coils making contact so that the coil that is in the angle where it does the most efficient job of powering the axle will be the one getting power. Paper 2, higher marking scheme. To follow in next video, because I'm almost out of time.